what you're going to learn in this video and be curious about is the art of spotting patterns. Now, what is this? Human beings, right? We are tool builders, I told you. There's one more thing about us, which is that we are lazy. If we can tell someone very quickly, hey, and they do all of the work like a computer, we would love it. So what we do, how do we make our job easier with laziness? One of the ways is to spot a pattern and then make the other thing just do it again and again instead of us having to tell it over and over and over and over in a boring way. Let me give you an example. The simplest example I can think of is, let's imagine you have a robot dog or something and it has to walk 10 steps forward. You can say move forward, move forward, move forward, move forward 10 times. Whether or not the robot gets bored, I don't know if computers get bored, but we definitely will. So what you'll want to do is repeat 10 times, move forward. And that's much simpler for you because you're lazy, right? That's an example of the simplest example I can think of a pattern, which is moving forward 10 steps is basically just moving forward one step 10 times. Maybe not super useful for us to learn how to identify these kind of patterns, right? What we're going to do today is take these repeating patterns, put them in what's called a repeat loop. And we're going to talk about why it's called a loop and by looking at some examples. Are you ready? Let's jump. Let me change my screen. I want to bring some coding into the screen. Let's go here and let's do this. So hopefully you can see my, you can see this person on top. We're going to draw with code today to use an example. And what I'm going to do is I'm actually going to draw a square. And I'm going to see if there are any repeating patterns in drawing a square. And what I want to do is draw a square that's like, say this, this, this. Okay, I didn't draw a square very well, but you get the picture. So how can I do this? Maybe there's a repeating pattern, right? My repeating pattern is that I draw a straight line 4 times. That's what a square is. So maybe I can go into this, repeat 4 times. And if I draw a straight line, I should get it. I'm going to draw a straight line. Over here in this particular place, drawing a straight line, the way I tell it to a computer is by saying move forward some pixels. Now you might have seen this before, this word pixel. If you haven't, all it means is that it's a tiny step you're taking. So 50 steps, move forward 50 steps is basically draw a line of 50, length 50. So do you think this will work? Let's see. I'm not going to hit run. What I'm going to do is predict. I'm going to read the code and predict. So what does my computer do when it sees a repeat loop? It says repeat 4 times. Okay, it remembers the number 4. It goes down, move forward by 50. So if I'm the computer, then if I'm very obedient, okay, as a computer, it never disobeys. So I'll move forward by 50. Then I'll see this thing and I'll go back all the way. That's why it's called a loop. Like I'll go back all the way and ask, okay, what should I do again? I've already done it once. So I have 3 more times to do it. What? Move forward by 50. Oh, I'll move forward again. Oh, 2 more times. I'll go again. Then back again and I'll do, okay, 1 more 50. You see where this is going, right? This is not going to draw a square because I did not turn. I forgot to turn. So let's see if our prediction is correct. Our prediction is this will not work. Run it. Exactly what we thought will happen, right? So what should I have done? I should have also put a turn, right? Let me do that. Let me actually get rid of the repeat, but I want to find out what the exact pattern here is. Because I know that if I move forward by 50 steps or pixels, and then if I turn left, because I'm trying to draw the square upwards, then this person I have to turn left by some number, right? You may be familiar with degrees, or if you've never seen degrees before, then 90 degrees is where you just like turn, if you're facing straight, turning left, you have to turn by 90 degrees. You can see it over here, right? That's 90 degrees. Don't worry too much about it now. And then if I move forward by another 50 pixels, I would have drawn 2 sides of this square. Can you see that? Perfect. Now let me put a repeat. Because I know if I can draw 2 sides of a square, let me first see if this works. You always want to be careful. It works, right? But this is not a square, it's 2 sides of a square. Let me put a repeat loop. Repeat and repeat this 2 times, right? Oh, not 0 times, 2 times. And let's see what happens. I want you to predict what do you think will happen. Now let's see. Repeat 2 times. I'm going to become the computer now. This is how I will think as a computer. Okay, when run, I'm alive. And then I go, when repeat 2 times, I'm like, okay, 2 times I should do something. And I'm going to go move forward by 50. Okay, I'll move forward by 50. I'm super obedient. And then I turn left by 90. Okay, I've turned left. I'm waiting to go. I'm not yet gone forward. And then I see move forward by 50 again. Then what I'm going to do, I'm going to move forward. And then I've done these 3 lines. What will I do? I see a loop, right? The loop has ended. So I'll go all the way back. And I'll ask, okay, I've done it once already. I'm going to do it once more. And what will I do? I'll see again, move forward by 50. I'll be like, okay, this is where I was facing upwards. I'm going to move forward again by 50. And then turn left. And then move forward by 50 again. This is what I'll draw. That is not a square. Let's see if our prediction is correct. So this will not work. So it did not do what we wanted, the square. What did we miss? So this is the thing about when you put a repeat. When I put a repeat, I should be very careful about when I'm ending the loop, right? What am I putting inside as the repeating unit, repeating block? So let's see. What should I add here? Can you think of it? Let's reset. I have to make sure that I move forward, turn left, move forward, and then turn left again so that I'm exactly back to the starting point. Let me show you what I mean. So turn left again by 90 degrees. Now this should work. Why? Take a moment, think about it. So that's how you draw a square. Now notice what we did, right? We repeated twice. Move forward, turn left, move forward, turn left. Did we identify a pattern? Yes. The pattern was these 2 sides, we're just drawing them twice. But you must be feeling weird right now. I am. Because I can see that, hey, even within this repeat, it looks like something is repeating. Move forward, turn left, move forward, turn left. So there is a smaller repeating pattern. The first step is to find the right repeating pattern so that you can put it in a repeat block. But the second step is asking, is this the smallest? And then trying to find the smallest. Why? Because it's kind of satisfying to know that you've found the smallest pattern. It's just fun that way. So what I'm going to do here is I'm going to get rid of these 2 and then leave the block just this way. Will this work? No, not really, because I'm just repeating 2 times, right? I have to repeat this 4 times. Do you think this will work? Make a prediction. Okay, let's see. Before I'm touching the code, I'm going to clear drawing and I'm going to become the computer again and see if, let's reset this. And I'm going to see if it makes sense to me. Repeat 4 times, move forward by 50, turn left by 90. So the computer goes, okay, I need to repeat this 4 times. And then I'm going to go move forward by 50. Okay, move forward by 50. And then I'm going to turn left by 90 degrees. I've not yet gone forward. And then I'm going to climb all the way here. And ask, okay, I've already done it once, 3 more times. And then I'm going to go move forward 50, turn left by 90. And then go all the way again. Now 2 more times. So the computer is remembering this number 4, 3, 2. It's counting down in its head, in its brain. And then over here again and then down. That's the 3rd time. And then the last time it again does it comes again over here and then asks, what should I do again? Move forward, turn left. It doesn't have to do that last turn left, but it does it anyway. And then waits exactly where it started. That's what I predict this particular code will do. Let's see if that is true. Let's clear the drawing. It did exactly what we wanted it to do. Drew a square and came and started facing right this way. Perfect. So you're getting a sense of how the computer thinks about repeat loops. Let's draw one more. I want to draw a staircase now. Don't ask me why and all. Just like that. Okay, I'm picking whatever example that comes to my mind that I can use to talk about loops and repeat and patterns. So maybe you don't want to draw a staircase. It's fine. How do I draw a staircase? Maybe this is how I want the staircase to look like. Yeah, that's what I want. Then I have, okay, let me increase it. So it's 1, 2, 3, 4 steps. That's what I want, some length. So how do I do this? I'm going to have to identify the smallest pattern and then code, right? What do you think the smallest pattern is? It looks to me like the smallest pattern of a staircase is a step, right? That's what I want. So this is the step and I'm just going to code it 4 times. I should be done. So let's go do this. I feel ready because a step is basically I want to move forward by, I'm making a length of say 30 pixels, 30 steps that is. I want a step of size 30 and then I'm going to go turn left so that I can, is it left or right? I always get confused. It's like going to be this way, it's going to be left so that I can go up. and then I have to move forward again by 30. Oh, I have to put the angle. Let me put the angle. Yeah, let me put the angle. So 30, 90, 30. This is one step. I need how many such steps? 1, 2, 3, 4. Because I need 4 steps, I'm going to put like a loop and put a repeat 4 times. There it is. This should work. Make a prediction. Okay, let's see if it actually works. Before I actually try it, I'm going to become the computer and see what this code would do. Right? Repeat 4 times. So the computer goes, okay, I have the number 4 in my mind. What should I do 4 times? See, the computer doesn't know what we want it to do. It'll just do what we ask it to do. So it's going to go move forward by 30, turn left by 90, it's ready, and then move forward by 30 again. That's the first time it runs this loop. Then you know it's a loop. It's going to climb all the way back here and ask, okay, 3 more times I should do this. What am I doing? Move forward by 30. So where is it facing right now? Right? The last time it moved forward, it was facing upwards. It's continuing to face that. Nobody asked it to turn. So it will do move forward 30 again, upwards, and then turn left by 90 somewhere there, and then move forward by 90, right? Turn left and then move forward again. Something, definitely not a staircase. This will not work. Let's see. We should be correct. So we have the correct wrong answer, I think. So something like a square it drew when we wanted a staircase, because we didn't find the right repeating pattern. We missed a small piece. What did we miss? What we missed was, let's see, when we were reaching the staircase, right? Let me just draw it out for you. When we did the staircase, you have to end up turning right over there as a final step so that it can start again exactly this way. So it's facing, this person is facing towards the right. Over here, he has to come back facing the right. If not, the repeating pattern is not working because the computer does not know it's supposed to turn right. It'll just do what you ask it to do. So if I add this, let me add it, which is a turn right or turn left? Turn right by 90 degrees. Do you think this will work? Will this draw the staircase that we want? Make a prediction. Okay, let's try it out this time. Like repeat 4 times, it's going to go move forward, turn left, move forward, turn right. I'm going to wait there and then repeat it. I think this should work. Let us see. That it did. So what did you see? If you're drawing a square, then what you can do, as you can see here, is find the smallest pattern. In the case of a square, it's basically a straight line and a turn. Done 4 times. In a staircase, it's straight line, turn left, straight line, turn right. Done how many ever number of times you want. Right? Examples of finding small patterns. Now, one of the reasons this is called a loop, like you saw, is the computer basically takes whatever your code you've written within the loop, within the repeat block, and goes, okay, 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 climbs up again, okay, 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 climbs up again. So it's going in loops, and that's why it's called a loop. Repeat loop is one of the loops. There are loops called for loops, while loops, until loops. There are a few of these that each of them are kind of just different flavors of this idea of doing the same thing until something happens or while something is true. These are called just loops. So the key piece here is that what you're going to do in the rest of the puzzles is, as you find something that you need to do, you're going to ask, is this problem having some other smaller problem in disguise being done again and again and again? And if it is, put it inside a repeat loop. But why? Why should I put it into a repeat loop? I'll just put it like that only. It's a good point. But the point is, when you put it inside a repeat loop, one, you're first being lazy. You don't have to write too much code, which is always nice. Second, you're also showing somebody else who reads, oh, it's just a repeating thing. It's making it more beautiful, easy to read for them, right? And also just generally, it's helping you exercise this muscle called computational thinking that we keep talking about, where you're able to take a big looking problem that looks kind of scary and say, hey, this is just these smaller problem done again and again and again. So all the best in exercising this muscle of computational thinking and figuring out how to break a big problem into its smallest, most beautiful pieces.